That means that y is equal to 3 times 2 minus 7, which is equal to 6 minus 7, which is equal to negative 1. That means that our coordinates there are x is equal to 2, y is equal to negative 1. And I also told you that our y value is equal to negative 6, and I want the corresponding x value. Again, easy to do. All I do is substitute that negative 6 into the y. That means that negative 6 is equal to negative 2x plus 5. Take the negative 2x across to make it positive 2x is equal to plus 5 plus 6, which is 11. That means that x is equal to 5 plus 6, which is 11 over 2. That means that our coordinates here are 11 over 2 and a y value of negative 6. Let us now take a closer look at the gradient. I'm going to start with two parallel lines. The first graph I'm going to sketch on a Cartesian plane is the line y is equals to 3x minus 4. On the same set of axes, or on the same Cartesian plane, I'm going to sketch the graph y is equals to 3x plus 2. Notice something about these graphs. They are parallel. What else can you see about the graphs? They both have the same m value or the same gradient. They both have a gradient of 3. That means that both of these graphs have a slope of 3. Hence they are parallel. That brings us to the first rule when dealing with gradients. When lines are parallel, the gradients are equal. Alternatively, when the gradients are equal of two lines, those two lines are parallel to each other. Let us now look at perpendicular lines. Remember, a perpendicular line, or rather perpendicular lines, are when lines form an angle of 90 degrees between them. We are going to use basic trigonometry to define a rule we can use for when we are working with lines that are perpendicular to each other. We are now going to look at the relationship between gradients of lines that are perpendicular. Now I've drawn a triangle ABC in here, with AB the hypotenuse and CA being perpendicular or right angled with CB or BC. Let us start. I'm going to start by proving that this is a right angled triangle. You don't need to do that whenever you're working with perpendicular gradients. I'm just doing that to show you that this is in fact a right angled triangle. The way we're going to do that is use the distance formula. The distance CB is going to be given by y2 minus y1, which is minus 1 minus 1, which is minus 2 squared, which is positive 4, plus x2 minus x1, which is 3 minus 1 squared, which is just 1. That means that the distance CB is given by square root 5 or root 5. Distance CA is going to be given by y2 minus y1, which is 2 minus 1, which is 1, squared is 1, plus 4 minus 2, x2 minus x1, 4 minus 2 is 2, squared is 4, which is also going to give us root 5. AB is going to be given by square root of y2 minus y1 minus 1 minus 2 is going to give me minus 3, squared is positive 9, plus 3 minus 4 is negative 1, squared is positive 1, so it's 9 plus 1, which is equal to square root of 10. If this is in fact a right angled triangle, it should follow that AB squared is equal to AC squared or CA squared let's work with CA squared, plus CB squared. The reason for that is that in a right angled triangle, the hypotenuse squared is equal to side A squared plus side B squared. AB squared root 10 squared is equal to positive 10. CA squared is equal to 5 plus CB squared is equal to 5. 5 plus 5 is equal to 10, which means that this holds true, that ABC is in fact a right angled triangle. That means that AC is perpendicular. AC, we now know, is definitely perpendicular to CB, which means that that's a right angled triangle. Now let's look at the gradient of AC. The gradient of AC, or CA, is going to be given by y2 minus y1, which is 2 minus 1, over x2 minus x1, 4 minus 2, which is equal to 2 minus 1 is 1, 4 minus 2 is 2, so our gradient there is positive a half. Our gradient of CB is equal to y2 minus y1, which is minus 1 minus 1, over x2 minus x1, which is going to be given by 3 minus 2, which is equal to negative 2 over 1, or negative 2. Now remember, at the outset I said that we are looking for the relationship between the gradients of perpendicular lines. It doesn't seem that there's a relationship just yet, does it? 1 over 2 and negative 2, the 2's are the same. But watch this. If I multiply these two gradients, it gives me an answer of negative 1. And you're going to find that is a general rule for working with gradients that are perpendicular. The one gradient multiplied by the other gradient is equal to negative 1. That means that if I have a gradient of negative 3 over 4, what is going to be my gradient of the perpendicular line to that line that has the gradient of negative 3 over 4? We don't know, we just know that it's the perpendicular gradient, but we know that it has to equal negative 1. So to get rid of that times negative 3 over 4, we're going to say multiplied by negative 4 over 3, which is going, by the way, that was negative 3 over 4, which is going to give us an answer of positive 4 over 3. So the perpendicular gradients multiplied by each other are always going to give us an answer of negative 1. Now there is an easier way of doing this. We just look for the negative inverse of it. For example, if our gradient is 2 over 5, our perpendicular gradient to that line will be negative 5 over 2. If our original gradient was positive, let's say negative 3, our perpendicular gradient, now that's negative 3 over 1, that means that our perpendicular gradient will be positive 1 over 3. All we're doing is swapping it around and changing its sign, either from positive to negative or negative to positive. And that there is the relationship between gradients of lines that are parallel. Now let us look at theta, the size of angle theta of CB. So far we've looked at the angle of inclination theta of a line that has a positive gradient. Now let's work at that one. The angle of inclination